Alrighty, today I want to go ahead and take a look at Lesson 10, Algebra Review. But first, we need to understand the following items that we have presented on our screen. The first thing I want you to take a look at is something called a variable. A variable is basically a letter or symbol that represents an unknown number. Usually we use the letter X to represent some things or try to solve for that, right? You probably have heard of something called solve for X. But sometimes we use different letters or symbols such as A, Y, and Z, or any other letters that we know or can think of in the alphabet. Now let me go ahead and provide you an example. Let's say that if X is equal to 2, then what is 2X plus 2? Okay, so I understand that X is equal to 2 here. And because X is equal to 2, I look at this expression here, I have 2X plus 2. This means 2 times X, so I'm just going to replace this X with this 2. So 2 parentheses, whenever you're replacing something, use parentheses, especially when you're multiplying. So 2 times 2 plus 2, 2 times 2 is 4, plus 2, well, that's going to give me 6, okay? And that's how this will come in handy. You're going to do this a lot in geometry where you solve for X and then plug something in just like we did here to figure out measurements, okay? So that's what a variable is. It's basically a letter or a symbol that contains or represents an unknown number. The next thing that I want to take a look at is something called a term. Now, a term is a single number, variable, or number, and variables multiply together, which we can take a look at an example here. So here's 1, that is a single number, it is a term. 2, that's a single number, that's also a term. -5 is a number and is a single term. Then we have that variable, which is also a term. Then we get into the territory where the variables are multiplied together. We have X and Y, X times Y, to be exact, that is a term. And then here we have 2, the number, and then X, the variable. They're multiplied together. That is a single term. So if I were to give you an example of these terms, here's a term here, and here's a term here. This is 2X plus 3. The 2 is the single number, the X is the variable. They are multiplied together, and that creates one term. And then it is separated by an operation here, a plus or a minus. So you have 2x plus 3. How many terms do I have here? Well, I have 1 and then 2. Okay, so we have 2 terms. So that's going to be helpful when we're getting into the territory of combining like terms, but we'll get into that right now. Now, combining like terms is basically the following. In order for you to combine like terms, you have to have the same variable and it has to have the same exponent. Then we add or subtract depending on the situation. For instance, I have 5x plus 2x. Since these both have an x and they have the power of 1 for each of them, right? There's an invisible 1 when you just have a regular x, right? You can go ahead and combine. So 5x plus 2x, since I have 5 x's here and you add 2 x's here, that's going to give you 7 x's. In this case over here, you cannot combine the like terms. And the reason why you cannot combine the like terms, yes, you can see that they both have x's. These two terms here have x's, but they have different exponents. And since they have different exponents, you cannot combine, so you leave it as this. 5x plus 2x squared is just simply 5x plus 2x squared. 5x plus 2x, the fact that it has the same variable and the same exponents, you can combine by just simply adding them, okay? The distributive property. The distributive property states that if you have A times the quantity B plus C, so if there's a number in front of the parentheses where the parentheses has terms inside of them separated by operations, you can go ahead and distribute the outer to each inner, okay? So for instance, I have this number in front of the parentheses here, all I have to do is I do a times b, which will just give me ab, and then a to c, which is a times c, ac, and that's how you do it. All you're doing is just you're multiplying to each term whenever you're dealing with something called the distributed property, okay? So now that we have all of these items taken care of, let's go ahead and take a look at examples of combining like terms, okay? So, combining like terms, once again, they have to have the same variable, and they have to have the same exponents. But I want to go ahead and just look at, this situation right here, a real life situation. We have dog plus 2 dogs. Okay, well, dog plus 2 dogs, if I add those together, how many dogs are there? Well, here I have a dog, which implies, singularity, or not singular, it's singular, right? It's 1. Then I have these 2 dogs over here. So you're saying, okay, I have 1 dog plus 2 dogs, that's just gonna be 3 dogs, right? All I'm doing right now, y'all, I am just using what I know about counting and adding and using the things that I've learned since I was a baby. Okay, that was pretty straightforward. Okay, so again, I want to emphasize something. Since this is a dog, it's singular. It is automatically implied that it's singular, therefore there's an invisible 1 in front of the word dog. That's something called the coefficient, right? The number in front of the variable. If I were to give you something like this, I'm going to take this situation and apply this into more of an algebraic sense. 1b, I have x plus 2x. This is very, very similar to the dog plus 2 dogs, okay? Here I have a singular x, and I have to add that with the 2x here. This singular x means that there's an invisible 1 here. So you're going to ask yourself, what is 1x plus 2x? 1x plus 2x, that's going to give me 3x. How simple is that? Again, you can only combine these terms if they have the same variable and the same exponent. So again, these x's, they have a invisible 1. All right, let's go ahead and take a look at this example where we're dealing with more animals. Okay, so I take a look at the problem. I'm like, okay, I see dog plus 2 dogs plus a cat plus a zebra. Can I combine anything here? Well, I notice that I have a dog plus 2 dogs. That means that we have 3 dogs in total. Then I take a look at this cat plus zebra. Well, are there any other cats in this problem? No. Are there any zebras? Or are there any other zebras in this problem? No. So what that means is I'm just going to write plus cat plus zebra, and this is my answer. Okay? Because I can combine these, I did. However, I cannot combine these, therefore I leave it as is. Okay? And that is your answer. This is how you're combining like terms in the real world. Now I'm going to go ahead and bring that to algebra world. So let's take a look at this one. Very, very, very similar to the problem that we just did. X plus 2x plus y plus z. I have x here, 2x here. They have the same variable. They have the same exponents. This means that I have 3 x's. So 3x. And then I take a look at the y's. Do I have any other y's in this problem? No. Do I have any other z's in this problem? No. So that means you're just going to write plus y plus z. Okay, so that is your answer. So this is your answer for number 2A, and this is your answer for 2B. Okay? Now, I want to go ahead and take a look at number 3. You want to ask yourself, can I combine the like terms here? Do they have the same variables for me to combine the like terms? Well, I have an x here in this term, and I have a y here in this term. Since they have different variables, I cannot combine the like terms, therefore I just leave it as is. So 2x plus 4y, and this is my answer. Okay. The rule for combining like terms is they have to have the same variable and the same exponent. Okay. All right, so that's pretty much combining like terms. Let's take a look at the distributive property. Okay, the distributive property, you multiply the outer term to each inner term. I take a look at number 1. I have 5 times the quantity, 2x plus 3. Since I have a number in front of the parentheses, you will distribute. So let me go ahead and use my arrows to help me multiply to each term. I'm going to have 5 times 2x, so 5 times 2x plus 5 times 3. 5 times 2x. What you do in this situation is, since there are 5 2x's, it's just going to give you 10x. So that's going to be 10x. And over here, 5 times 3, you should know that. That's going to be 15. Can I combine anything in this problem? No, you leave it as is. Okay, so this is your answer. Okay, so if you want to get to the point, all you're just doing is you're multiplying the 5 and the 2 together, and then you slap on the x, and then the 5 and the 3 together. That's going to give you plus 15, so make sure you put that plus sign there, and then the 15. And that's your answer, okay? Number 2, let's take a look at this thing. This is a number in front of a parentheses. This is saying, okay, I take this 1/2, and I multiply that to 6y, and then I take that 1/2 and I multiply that with 2. We suck at fractions. It's okay. I sucked at fractions. Let's go ahead and slow down and figure out how to approach this. 1/2 times 6y. Y'all, that's just another way of me saying 1/2 of 6y. What's a half of 6y? Well, that's just going to be 3, then slap on the y, and then I take a look at this 1/2 here again, multiply that with 2. What's a half of 2? You should automatically tell me it's 1. So 3y plus 1. So 3y plus 1, and that is your answer. How easy was that? All right, distributive property is done. Combining like terms is done. Let's go ahead and take a look at inverse operations. Now, inverse operations, this is going to help us when we're getting into the territory of basic algebra. We need to know what's the opposite of whatever operation I am presenting to you. So the opposite of addition, you should automatically tell me that is just subtraction. The opposite of subtraction, well, that's going to be addition. The opposite of multiplication, that's division. And then lastly, the opposite of division, that's just multiplication. If we know all of this, then we're ready to take on the basic algebra that I'm going to present now. Okay? One-step equations. Why are they called one step? Because it just requires one step. My goal here is to get the variable by itself, and you're going to apply the inverse operation, okay? So let's take a look at number 1. X plus 5 is equal to 10. Where's the variable? The variable is right here. All I need to do is get it by itself, but there's something in the way. This plus 5 is in the way. I cannot have x by itself unless I get rid of it. Since we know that this is plus 5, what's the opposite of addition? Well, again, the opposite of addition is just subtraction, right? So all I have to do is I'm going to subtract both sides by 5, right? So again, because I have this plus 5 here, the opposite of addition is subtraction, so I need to do minus 5 here, and whatever you do on one side of the equal sign, you have to do on the other side of the equal sign. Then I am going to add vertically, just like so. See, there's nothing here, so that means x can go on that left side, and this plus 5 minus 5, or 5 minus 5, that's just 0. I don't write anything. Then I bring down that equal sign. Then I take a look at this. 10 minus 5, that is just 5. That is just 5. And that is your answer. So x is equal to 5. Can I verify if the equation is, or if x is equal to 5? Can I verify if x is equal to 5? Yes, you can. Because remember, since we solved for x in this case, what is x here? Well, we know that x is 5, so replace this x with 5. 5 plus 5, which is equal to 10. Does the left-hand side equal the right-hand side? Does the left-hand side agree with the right-hand side? Yes, it does, because 5 plus 5 is 10, and 10 is just 10 on the right side. Let's take a look at number 2. Y minus 7, which is equal to 8. The variable is right here. It represents the, variables are letters or symbols. This is what I want to get by itself. That minus 7 is in my way, so I'm going to apply the inverse operations. So the opposite of subtraction is basically addition. So plus 7 here, plus 7 here. I am going to go a little quicker, so that's just going to be y is equal to 15, and that's it. Okay, and that's my answer. Number 3, 3z is equal to 9. One thing that I want you to understand is when you have 3z or something like this, remember, it's 3 times z. Okay, that's 3 times z, just all in one. So I have 3z, which is equal to 9. What is the opposite of multiplication? Because this is multiplication. Well, that's just going to be division. So you need to do this. You're going to divide both sides by 3. Okay, 3z divided by 3. What's 3 divided by 3? 1, right? So that cancels out. And then what happens to that z? It's just going to follow that 1. Okay, so that's just going to be 1z. Or you can just write z, because it's automatically implied as just 1, right? Z is singular, therefore there's an invisible 1 there. You don't need to write the 1, just leave it as is. Z is equal to 9 divided by 3. 9 divided by 3 is just... Sorry, I'm trying to figure out where my tools are. Z is equal to 3, and this is my answer. Can I verify and check if Z equals 3 is correct? Yes, I can. Well, how I do this is I take a look at the original problem, the 3Z is equal to 9. I do 3... And then, since I have that z there, I gotta use my parentheses like so. Sorry, not z, it's just gonna be 3, which is equal to 9. 3 times 3 is 9, which does agree with the left-hand side and the right-hand side. Or, sorry, they both agree in that case, okay? So that's the answer, z is equal to 3. Now, I have 1/2 of a is equal to 3. Take a look at what I wrote over here. 1/2 is the same as 1 divided by 2. Because this is division, the opposite of division is going to be multiplication. What I'm going to go ahead and do is I multiply by the reciprocal. 1/2 of a is equal to 3. I'm going to put parentheses here and parentheses here. Then I'm going to write the reciprocal of that, right? All I'm doing is I take this 1/2, flip it, and write it right outside of the parentheses here, and also the parentheses over here, okay? Well, this is how it works when you are multiplying fractions. They are supposed to be done horizontally. For instance, this 2 times 1 here is 2, so I'm going to write 2. And then this 1 times 2 over here is also 2. So I have 2 divided by 2, which is a. 2 divided by 2, 2 divided by 2, and a. Then 2 divided by 2 is just 1, right? And then over here, 3 times 2 over 1. The 3 has a 1 in the bottom. So all I did was 3 times 2, which is 6. And then 1 times 1 is going to be 6 over 1. Okay, so what does that mean? That means my answer is a is equal to 6 over 1, or you can say a is equal to 6. Okay, and that works. Now, you don't necessarily need to you don't necessarily need to go ahead and say 2 over 2, then write the a. You can just go ahead and just cancel this out because they are opposites of each other, right? 2 over 1 multiplied by 1/2, they cancel out. So all you could do here is just write the a. You can skip that part and just write a, and then proceed to multiply as so. 3 times 2, which is 6, then over 1. So 6 over 1 is just simply 6. Okay? Now I want to get into the territory of multi-step equations. The reason why it's called multi-step equation is because you're performing multiple steps. The first thing that you should look at is, are there any combining like terms that you have to do, or distributive property? If so, do that first, then undo the addition or subtraction, then undo the multiplication or division. If I were to take a look at number 1, I got 2x plus 3, which is equal to 7. I don't see CLT. I don't need to apply distributive property. I'm going to undo the addition or subtraction first. So this is the variable, which is with the 2. Here's my plus 3. I need to get rid of that plus 3. So the opposite of addition is subtraction. So minus 3 here, then minus 3 here. So what am I going to do is I am going to add vertically. So I have 2x is equal to 4. And I'm not done. I still need to solve for this x here. It has to be by itself. I have this 2x. It has to be by itself, this x over here. So what I need to do is I got to divide both sides by 2. Because again, 2x is the same thing as 2 times x. So the opposite of multiplication is division. So what am I left with? X is equal to 2, okay? 2 divided by 2, though that cancels out. I'm left with that x. Then I have that 4 divided by 2. That should give you 2, okay? Let's go ahead and take a look at the second problem here. 1/3 r minus 5 is equal to 6. Do you see CLT or DP? No. So that means I have to undo the addition or subtraction first, then multiply or divide. Here's the variable. The r is right there. This minus 5 is in the way, so you're going to go ahead and add both sides by 5, okay? So what does this mean? We're going to add vertically. So I have 1/3 r. The minus 5 plus 5, those cancel out. And then I have that 6 plus 5, which is 11. Okay? Then I have this 1/3 r. So remember, 1/3 is the same thing as 1 divided by 3. What's the opposite of division? Multiplication. So you're going to multiply by the reciprocal. All I'm going to go ahead and do is I'm going to write 3 instead of just 3 over 1, because 3 over 1 is the same thing as 3, right? 3 divided by 1 is just 3. Whatever I do on one side, I have to do on the other side. So then 3 times 1/3, or if you want to, say it the opposite way, 1/3 of r, or sorry, 1/3 of 3, that's just going to give you 1. So I have r equals 11 times 3, which is 33. So r is equal to 33. Okay, pretty simple stuff. Okay, let's take a look at number 3. I have 8 times the quantity 3b plus 1, which is equal to 16. Do I see descriptive property or combining like terms that I have to do? Yes. So, since there's a number in front of the parentheses, you're going to take that outer term and multiply to each inner term. So then 8 times 3b, we did this before, that should be 24b. Well, we didn't do the same thing before, but we did something similar. So 8 times 3b is going to be 24b. And then over here I have 8 times positive 1, and that's just going to give you plus 8, which is equal to 16. I'm dropping the equal sign, I'm dropping the 16 down. So now I have a regular problem that looks very similar to this one over here. What am I going to do? I am going to undo the addition, or I'm going to undo the subtraction. This is the variable which I want, but the plus 8 is in the way, so I need to subtract both sides by 8 here. So I have 24b is equal to 16 minus 8, that's just going to give you 8. Then I need to divide both sides by 24. So I have b is equal to 8 over 24. And you either, when you get into this stage, when you have 8 divided by 24, you either reduce or give it as a decimal, depending on what the question asks you. In this case, I am just going to reduce, so I need to figure out what number goes into 8 and 24 at the same time. I'm thinking 8, so I'm going to divide. Sorry, I have the wrong thickness here. By 8 here and divide by 8 here. 8 divided by 8 is just 1. And then 24 divided by 8 is just 3. So that means that b is 1/3. b is 1/3. Okay. Number 4. Any combining like terms or distributive property I have to take care of. Yes, I have this a plus 2a. That's going to be 3a. Drop down that plus 1 and the equal 7. Then I need to go ahead and undo addition of subtraction. So minus 1, 3a is equal to 6. And then I have 3a is equal to 6. That 3a means 3 times a, so the opposite of multiplication is going to be division. So a is equal to 2. And this is my answer. Okay? Later on the road, I am going to get faster. This is just a review. You should already know how to do all of these problems if you're in geometry. But this is a good review, and I highly suggest that you go and practice over and over and over again until you feel comfortable doing these basic equations, right? Okay, let's go ahead and take a look at number 5. I have 1/2 of 4m plus 9, which is equal to 10. Because I see a number in front of the parentheses, that implies that I have to do the distributive property. So 1/2 of 4m, and then 1/2 of 9. 1/2 of 4 is just 2. Then throw in that m. Don't forget that m there. And then I have 1/2 of 9. 1/2 of 9 is just 4.5. Okay, which is equal to 10. Well, I have 2m is equal to 4.5, which is equal to 10. Once I get into this stage, after applying the distributive property, you need to undo the addition or subtraction. So minus 4.5 here, minus 4.5 here. So that should give you 2m, which is equal to, well, 10 minus 4.5, that's going to give you 5.5. So let me see, what's 5.5 divided by 2? That should give you m equals 2.75, okay? And how do I get m equals 2.75? How do I get from here to here? All I did was divide both sides by 2, okay? Again, 2m is the same thing as 2 times n. Opposite of multiplication is division, so I divide both sides by 2 there. So m is equal to 7.5, okay? All right, it looks like I have done all the examples, but there's one more thing that I want to, go over, and it's something like this. Let's say example 6, where you have something like 3/2 x is equal to, I don't know, let me think. Let's say 6, okay? Now, this is a little different because we were used to having fractions as 1 over a number, right? This time I have 3 over a number that's greater than 1, right? And I need to tackle this problem. This is 3/2 of x. That 3 over 2 is the same thing as saying 3 divided by 2. So in order for me to get x by itself, again, I have to take the reciprocal. I gotta multiply it by the reciprocal here. So that means that I'm going to put the parentheses here, and I'm gonna put the parentheses there. I'm gonna take this 2, and I'm gonna put that up top. And I take that 3, and I'm gonna put that in the bottom. This is me multiplying by the reciprocal. I'm just flipping the fraction. Okay? Now, whatever you do on one side, you have to do on the other side. Okay? And since we know that 2/3 times 3/2, because we are applying inverse operations, these things cancel out, and then I have x on the left side. Okay? And then over here, I have 6 over 2/3. How I handle this is you can say that 6 is the same thing as 1, right? And then you're going to multiply that. You're going to multiply across. You're going to do 6 times 2. 6 times 2 is 12. And then I have a division sign that I need to put there. And then 1 times 3, which is just 3. I simplify. X is equal to 12/3 is just, 12 divided by 3 is 4. And this is my answer. Okay? You don't necessarily have to put that over 1. You don't need to put, over 1 over everything. Unless you want to. That's totally fine. You can just look at it and you go 6 times 2, and then whatever that is, you divide that by 3, which I did over here. So get used to this type of problem. You're going to see that a lot in geometry. If you're struggling with these type of problems, this one right here, then I highly suggest looking up some more examples or come to tutoring and we can get that, figured out. Alrighty, I guess I am done with the review. Hopefully you enjoyed the video. Hopefully this video will help you and prepare you for geometry because you're going to be using algebra in the context of geometry. Okay? Alright, see ya.